A rotorcraft drops through a wall of orange haze. Below it, the ground slowly emerges. Not rock, not soil. A frozen landscape that has spent ages locked in temperatures most machines were never built to face. Then the number appears. -290 degrees Fahrenheit. At first, it sounds like a detail, just another harsh condition in a distant world. But as Dragonfly continues its descent, that number starts stripping away assumptions. This is not the kind of cold that makes a spacecraft uncomfortable. This is the kind of cold that changes the rules. The surface below is trapped in a permanent deep freeze. Water ice rises from the landscape like stone. Every exposed component is entering an environment where familiar materials can behave in unfamiliar ways. And this is not a rough estimate. Measurements from Cassini-Huygens established Titan's surface temperature at roughly -290 degrees Fahrenheit. Suddenly, the challenge is no longer reaching Titan. The challenge is what happens after arrival. Because before a single science experiment begins, before any exploration starts, every system has to survive a world cold enough to make ordinary assumptions questionable. Power, batteries, lubricants, long-term exposure. Components that work perfectly elsewhere now face conditions that push them into completely different territory. Dragonfly keeps descending. The haze thins. The frozen surface spreads out beneath it. And the mission's greatest threat is already waiting on the ground. Not a storm, not an impact. The environment itself. Inside Dragonfly's protected internal systems, a battle is already underway. The outside world is trying to pull heat away every second. So the spacecraft does something that would seem almost backwards. Instead of focusing only on generating electricity, it has to protect warmth. A cutaway reveals the contrast. Beyond the outer structure is a vast, frozen environment. Inside, critical electronics sit wrapped in thermal protection, isolated from the cold pressing in from every direction. That pressure removes options. The idea of simply building a tougher rover and operating it with familiar methods starts to fall apart. Far from the sun, available sunlight is weak. At the same time, the spacecraft's most important systems cannot be allowed to remain at Titan's ambient temperature. They have to stay warm. So at the center of Dragonfly is an MMRTG, a nuclear power source that generates both electricity and heat. The heat is not a side benefit. Thermal energy moves through the spacecraft's protected interior, while the frozen exterior keeps trying to drain it away. The mission architecture depends on that heat, because Titan's environment remains far below the limits where critical electronics can operate. That changes what survival means. The power source is no longer just supplying energy for a mission. It is helping keep the mission alive. And once that becomes clear, another assumption disappears. The cold is not simply an obstacle Dragonfly must endure. The cold is dictating how Dragonfly has to be built in the first place. The warm interior exists only because heat is being continuously generated and protected. If that thermal control is lost, the danger is no longer confined to a single instrument or a single system. The threat spreads to the spacecraft itself. Years of exploration now depend on a small collection of protected systems continuing to stay warm inside a world that never will. Then something unexpected happens. Dragonfly's rotors begin to spin, and the aircraft rises through Titan's atmosphere with surprising ease. Not fighting the air, using it. In mission simulations, Dragonfly lifts steadily upward, carried by an environment that behaves very differently from what many people would expect from such a hostile world. The assumption starts to crack. If Titan is cold enough to threaten the spacecraft itself, flight should be harder too. Instead, the opposite begins to appear true. Titan combines an atmosphere roughly 4 times denser than Earth's, with gravity only about 14% as strong. The result is visible almost immediately. A relatively heavy aircraft moves upward through thick air with minimal effort, as if the environment is helping hold it aloft. What looked like a major limitation suddenly starts looking like an advantage. Aerodynamic modeling showed rotorcraft flight is unusually efficient under Titan's conditions. The dense atmosphere gives the rotors more to work with, while the weak gravity asks far less from them in return. As Dragonfly climbs higher, mobility no longer seems tightly constrained. A route map stretches across Titan. New destinations appear. Then more, and more. Places that would feel distant to a conventional rover begin to look reachable. For the first time, the environment appears to be giving something back. The same world that threatened every warm electronic system inside Dragonfly now seems to be making movement easier than expected. For a moment, the numbers appear to favor the mission. The same atmosphere that threatens long-term survival is now extending mobility. Every new destination looks closer than it did before. The environment is finally giving something back. Dragonfly lands. The rotors slow. The aircraft settles onto Titan's surface exactly as planned. For a moment, it looks like the hard part is over. The route is complete. A new location has been reached. The atmosphere that made flight seem so effortless has done its job. Then nothing moves. Dragonfly remains on the ground. The mission enters a different phase. Science work begins. Systems continue operating. Heat must be maintained. Power must be managed. Preparation for a future flight quietly starts long before the next takeoff ever happens. And that cycle repeats. Fly. Land. Survive. Prepare. Fly again. The problem is that Dragonfly spends far less time moving through Titan's atmosphere than it does living on Titan's surface. The aircraft sits motionless in darkness and cold, while critical systems continue working inside. The environment that helped lift Dragonfly into the sky has not disappeared. It is still there, pressing against the vehicle during every stationary period between flights. That changes the meaning of mobility. Dragonfly must repeatedly survive long stretches between aerial relocations. The mission depends on cycles of landing, science operations, heating, charging, and preparing for the next journey. The aircraft may travel from place to place, but each successful flight leads directly back to the same requirement. Endure the environment. As Dragonfly remains parked on Titan's surface, thermal systems continue running even though the aircraft itself is not moving. The vehicle waits in the cold far longer than it flies through the air. And suddenly, the earlier confidence starts to break. Flight is not the entire mission. Flight only creates another survival cycle. The dense atmosphere may help Dragonfly reach new destinations, but every destination comes with another long exposure to the same unforgiving environment. Mobility and survival are tied together. One cannot exist without the other. By the time Dragonfly lifts off again, the true bottleneck no longer looks like reaching the next location. It looks like surviving long enough to keep reaching any location at all. Dragonfly launches again. The aircraft rises from one landing site, turns, and heads across Titan's landscape. Below, the terrain keeps unfolding. Ridges, plains, distant targets scattered far beyond a single region. And Dragonfly keeps going. This is where the environment reveals its final consequence. Titan's dense atmosphere and low gravity do not simply allow flight. they change what kind of mission becomes practical in the first place. The aircraft crosses terrain that would force a conventional rover into an entirely different reality. The next destination comes into view, then another beyond that. Scientific targets are no longer confined to whatever happens to exist near a single landing site. The exploration strategy itself changes. Mission planning centers on repeated relocations between locations rather than remaining trapped in one area. Movement becomes part of the mission's foundation. And suddenly the earlier assumption collapses completely. The extreme environment did not just make exploration harder. It forced exploration to become something else. Titan's atmosphere creates enormous survival pressure. It demands continuous heat, continuous power, continuous endurance against a world that never stops pulling warmth away. But that same environment also produces exceptional lift. The threat and the advantage come from the same place. As Dragonfly traverses Titan, the reason for its design becomes unavoidable. A conventional rover would solve the wrong problem. The environment changed what was physically practical, so the vehicle had to change with it. The result is neither a tougher rover nor a familiar spacecraft. It is a flying, nuclear-powered explorer built specifically for a world where survival and mobility are inseparable. In the end, Titan did not merely make exploration harder. It changed the definition of exploration itself. The environment that threatens Dragonfly is the same environment that allows Dragonfly to move. The danger and the opportunity come from the same source. On Titan, survival is not separate from exploration. Survival is the exploration strategy.